Hi everyone, my name is Thomas Kim. Today is January 22nd, 2020. This is my 7th episode about 3D graphics, Intel TVB, OpenCL, Vulkan using Microsoft C++. Before I explain 3D graphics, Intel TVB, I will explain some fundamentals about modern C++ programming. In this episode, I will explain how to use reverse range-based for loop and parallel STD for each algorithm. I will not explain how to implement reverse range-based for loop, but I will explain how to use it. Also, if you want to know how to implement reverse range-based for loop, please watch this video. In this video, I explained how to implement reverse range-based for loop. I assume you have watched my previous videos, especially episode 6 and all my previous episodes in this series. Without further ado, let's get started. Start Visual Studio Code. Open your working folder. Click this button, 07, reverse, range 4. Hit enter. Click this button, reverse.cpp. Hit enter. I will move it to this folder. It should be in this folder. Ctrl B. Define TVB suppress deprecated messages. 1. To suppress TVB deprecated messages include talk play fun, output HPP, include talk play fun, parallel HPP, include TVB spin mutex. I will use TVB spin mutex. Talk play fun, S stream, auto, and there, talk play fun, and there, new line, and flush. If this squiggle is annoying, Ctrl Shift P, edit configuration JSON. You have to set these environment settings. Then Ctrl S, Ctrl W. Auto, NL, talk play fun, NL. This is new line character, Auto, flush, talk play fun, flush stream to console without new line. Now void test reverse 4 int main. I will copy this function name here. We create a vector std vector int b. We initialize 1 2 3 4 5 6 7 8 9 stream b and there. If we want to display in reverse order, stream b in reverse, then we can use talk play fun reverse b. Now we will run this program. Start your command prompt, dir cd07 reverse range 4 cl ehsc std C++17 reverse.cpp tbb malloc lib fe m.exe. Hit enter. cls. So this is our original vector. This is displayed in reverse order. Now we can use range-based for auto e b stream e. We use nl. nl is new line character. Then we have to flush stream flush. Now we build once again. We define the flush here. It should be h. Now we build once again m. So this part of message comes from this code. Now we beast in reverse order. I will change it to Amdahl for auto E talk play fun reverse stream E and L. We have to flush stream flush. Now we build once again CLS. Now it is in reverse order. This message comes from here. Now let's learn how to use for each algorithm. Void test for each basic. I will copy this function name and paste it here. I will disable this part. cd b 1 2 3 4 5 6 7 8 9 from C++ 17 standard template argument deduction guide is working properly. If the constructor and the deduction guide is declared or implemented, std for each b begin, b end, auto reference e. This is lambda stream e and l stream flush. Don't forget flush or Amdahl. Otherwise, you cannot see the result. Now in the command line once again, we rebuild CLS so this vector is displayed properly. Now in reverse order, Amdahl std for each vr begin, vr end, handler auto, handler auto e stream e and l. Now let's try it. Okay, it works. We forgot stream flush. We forgot flush. CLS M. Now it is displayed in reverse order. Now let's try this using mutex t tbb spin mutex. Please note that this is a type defined in this header file. Now we declare a mutex t mutex. We declared an instance of spin mutex. std for each std execution policy parallel unsequential v begin v end auto e. Now this is lambda mutex t. This is the type defined here. Scope the lock mutex. So we have to capture this mutex like this mutex. Now stream e and l stream flush. We have to capture stream and L. Let's try it if it works. Wow, it worked. I will put here and there. CLS. This message comes from this line. Please note that this part runs in parallel. For each can run in parallel. So I will create a big vector int be 100. What? 10,000. It should be big B. We initialize std iota big B begin big B end. It should be B. Initial value int 1. This is initial value. We initialized big B starting with 1. Now it should be big B big B. Now we run it again. CLS. Please note that it runs out of order. 106, 97, 98, 92. It runs out of order because it runs in parallel. So we need lock because this stream is global, declared here, shared among multiple threads. It runs in parallel. Also, we can catch like this. Stream. Okay, this is also possible. Or NL. Please note that this is global stream. Global stream is captured. This is global end line. This also works. CLS, it also works. This for each algorithm with a parallel unsequenced has some limitation. I will talk more about for each algorithm in my next episode. I will post complete source code to my website. Please double click this link and download the source code and try it by yourself. We will use these algorithms in future episodes, so please make yourself familiar with these algorithms. Please subscribe to my YouTube channel. Thank you for watching.